Okay, so Mr. John, as we completed our module number 4, we are working with module number 5, or you can say lesson
Mm-hmm.
number 5. Okay,
Mm-hmm.
and in this we will be talking about static routing, our first routing lab.
Mm-hmm.
Okay, so these are the topics what we are going to cover in this. Okay,
Okay.
now same thing. Remember, because we are going to configure routing, so again it's just a repetition of the routing. That what is routing? So routing is a process of forwarding packet from one network to another network. Routing is used for creating communication between two different unreachable networks. Okay, and it is also used for finding the best path to reach from source to destination.
Mm-hmm.
Okay, and we have already discussed about the types of routing. Okay, so routing comes in two type: interior gateway protocol and exterior gateway protocol. Interior means the protocol which is working inside your organization. Okay, so inside our organization we use three type of protocol: static, default and dynamic. Okay,
Mm-hmm.
so a static is a manual routing for known destination. Like we say that okay, I want to go this place, so I will only configure path for that place. And if I want to go another place, and if there is no path in the routing table, okay, so I won't be able to reach there. Okay, but in default routing, you just configure default, so you will be reachable to each and every network, which is public network, right?
Mm-hmm.
And dynamic is automatic depending on your infrastructure and depending on the router which is connected inside your organization, you can reach all those networks. Okay, so we'll see those things now. See static routing. So static routing is also known as non-adaptive routing. Non-adaptive means it do not share its routing table. Same thing, it is a technique in which administrator manually configured and adds the route and what network in the routing table. And a router can send the packets to the destination along with the route defined by administrator manually. It's not the automatic. Whatever administrator will define, the routers will reach to those destinations.
Mm-hmm.
Now, in this technique, routing decisions are not made based on the condition or topology of the network. Okay, it's made by or defined by administrator. But in dynamic routing protocol, everything is automatic.
Mm-hmm.
Now, packet routing decision is configured manually before by network administrator. Now, means the routing is pre-configured. Okay, but in other dynamic routing protocol, when you configure routing protocol, okay, so automatically routing protocol will define the routing table. Here, administrator is defining. We will see how it will be done. Okay, so simple, you can see here a static routing table in static routing table is created, maintained and updated by network administrator manually. This provide a granular level of control over routing but quickly become impractical for large network. I can understand that yes, if administrator is defining everything manually, so there will be full control on the routing networks. But if you have to work on large enterprise network at that time, it is little bit difficult to be configured. Okay.
Mm-hmm.
Static routers will not share routing table with its neighbor routers. Okay, static routing do not provide fault tolerance. Means if one path is down, static routing will never use second path automatically. Administrator has to define it.
Mm-hmm.
If administrator will define, then static routing will choose. Otherwise, no.
Mm-hmm.
Now, if any changes to the routing domain, means if there is any changes in the routing topology, so it is not going to update automatically. So means manual intervention is required. Means manually administrator will come and define and make the changes. Okay,
Mm-hmm.
A static route administrative distance is 1. Okay,
Mhm.
and static route is always preferred over dynamic routes, means a static route is always best over the dynamic route. Okay, so if you
Okay.
have a static, means it is best than dynamic.
Really?
Yes, because its administrative distance is low.
Yeah, 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 yeah. Mhm.
Now, and a static route AD can be adjust also, so you can modify the administrative distance. If it is 1, you can change to anything. Okay, that is known as floating static route. We'll do that one, load balancing.
Mhm.
Okay, advantage of static routing. Okay, once. Okay, so the advantage of a static routing is that no overhead, means there is no overhead on CPU, because routing is always preferred by manually configured. So there will be, you will not find like CPU utilization is not there. Okay, now
Mhm.
it has, like, it has no not usable bandwidth. Okay, means like in a static routing, like, bandwidth is there for data sharing but no routing process. There is no
Mhm.
routing process. But like in other routing protocols, if you configure dynamic, so in dynamic, routing messages will be exchanged, like EIGRP will generate multiple type of messages, OSPF
Mhm.
will generate multiple type of hello message, okay, query message, different type of. But in a static routing, there is no any kind of message exchange between neighbors. That's why no bandwidth utilization. Okay,
Mhm.
and it provide security, as the system administrator is allowed only to have control over the routing to a particular network, means whatever network will be defined, according to those networks your system will communicate, and other network won't be able to communicate to your routers. Okay, this is advantage, but see the disadvantage. For large network, no support.
No support.
If network is down, okay, administrator has to perform manual routing again, manual changes again, if any topology is uh, disconnected, or if any network is disconnected, connected, everything administrator has to do manually. But if everything is done in if there will be changes in the midnight, then every time administrator has to be there 24 by 7. That's why most of the people prefer dynamic routing.
Mhm. Yes. Mhm.
Okay, note, if connected link to a neighbor is down, this is practical part. If you will do practical, then you will see. Okay, means whatever routing you will configure in your net, on your router, and if your neighbor is disconnected, your routing table will be automatically removed. Okay,
Mhm.
yes, we'll see that one. Okay, so now we have a practical part, no problem. Okay, so before practical, let me show you, we have uh, two type of static routing configuration. One is with exit interface, and one with next hop router IP. Okay, so you can configure with both. We'll work on this all. Okay, so now let's open our. Okay, so we are using this. Do we have a static routing lab? Static, no static. Okay, no problem. We can say static lab 1. In that we are taking routers. See how we are taking routers. So first we will click on the routers. Yes.
My genius also doing like that. What is the problem?
No, that is not a problem. That is the process to open GNS. Okay, so here you have to write static lab 1. Okay, now here we are going to take some routers, so we'll come here. We are going to take two routers. Okay, so we'll take two routers, router 1 and router 2. After that we will be taking two switches, so for that switch we will click here. Okay, are you getting? See, two router, let me explain you, let me delete it again. You know, drag and drop, right? If you want router, you come here,
Mm-hmm.
you just click here, you will have router. So you can take any router, but these routers are faster routers and new version routers. So I will drag router 1, router 2. Now you need switch, so you have to come here. This is for switch. See, browse for switches. So click here, I need two switches, so I will take this one switch. Okay, and here it will ask, you want to run the switch on your PC or on your VM. So yes, I want to run on my VM. Click select VM. Okay, then again I need another switch, same thing, browse, drag and drop, like select and click OK. Okay, now bring it little bit up, select. Now we have to work with PC, so you come here and select VPCS, virtual PC. Okay, VPCS, so drag, drop, select here, GNS. Okay, drag and drop. Okay, same here also, drag. Or if you do not want to drag and drop, so just right click and make it duplicate. You have both options. Okay, now
Mm-hmm.
see, we have to align it. Alignment, we have to make this lab perfect. So what you have to do, select this both router. Okay, right click and see, align horizontally. Okay, select this both. Okay, align horizontally means to making it, like perfect lab. Okay, like this. Now if you want to change host name, change the symbol, so select both and come here, change symbol, means change like a real switch. Okay, come here, custom, we'll come to custom and then select layer 2 switch. Okay, now it is like that. If you want to change the name also, select this and come here to change host name and say switch 1, switch 2, simple. Okay, select this, make it horizontally. Okay, okay, fine. Now we have to select these two computers. We want to change as a real computer or something like that, so you come to change symbol. Click on custom after that. Okay, and here we select desktop. You see, desktop computers. Okay, PC 1 and 2 you can put it here. Okay, PC 3 and 4 you can put it here with this switch, and then again you can align. And now part of connectivity, so for connectivity we can take cables, right?
Mm-hmm.
Okay, so for cable we can select this, add a link, click Ethernet because there is a single interface. Come to switch, switch has 8 interface, select anyone, no problem, single interface, anyone. Here from switch to router I can select any one. Here E0 by 1 to E0 by 1, again E0 by 0 to switch, and here you can select any one. Okay, okay, now we are bringing the networks here. So you have to click here ABC. Can you see here ABC? So if you click here ABC, you can see here this is the Ethernet port numbers. So you can remove these numbers. These are not important, but router interfaces are important.
Mm.
Let me increase the size little bit. Okay, fine. Okay, now here we can say we are using 192.168.10.0/24. Okay, or maybe according to lab we are using /29. Okay, fine, /29. Okay, and here we are using 192.168.20.0/29. Fine, and here we are using one network which is 12.1.1.0/30. Okay, so for that, if we want to configure, what we will do, we'll come here. Okay, and then we'll start all the devices. So you have to click here to start all the devices. Click yes. Okay, when all the devices started, that after that you have to click on this to have a console access of all the devices. Now router 1 you bring it here, and router 2 you bring it here. Now first we have to, according to this series, like we'll start this PC configuration router like that. Okay, we'll move like that. First we'll come to PC1. PC1, what IP address you want to give? So I want to give 192.168.10.1/24, and /24 means subnet mask, and the gateway will be 10.10. Okay, and sorry, you have to write here one command. Okay, file clear screen like that. Okay, now you have to write here, for I forget here, you have to write IP like that, and then click here save. Then again come to PC2, you write here IP 192.168.10.2/24, and then 10.10, and then save. Come here to your router 1. In router 1 you have two interface, one is E0 by 1 and E0 by 0, right? So you come here conf t interface E0 by 0, IP address 192.168.10.10, which is the this IP address, this here on this interface. Okay, so here what I'm saying, here we are assigning 192.168.10.10 IP. Okay, here, and here we are going to assign 192.168.20.10. Okay, 255.255.255.0, no shut, exit, then come here interface E0/1, which is my WAN interface, 12.1.1.1 252, right? Oh, sorry, I configured wrong IP, right? It is here instead of slash 24 it should be, it is slash 29, right? Okay, let me reconfigure. Okay, PC1 instead of slash 24 it is slash 29. Here you can see the label. Okay, so no need to worry, we just have to go here and here we will say 29.
Mm-hmm.
Okay, in 29 is not matching. Okay, or let it be okay, so in 29 we can say this as a 3, then is okay, and then save. Here we will come here 29 and here 3, save it. Okay, fine. Then we'll come to R1, and R1 we have to change a little bit. Conf t interface E0 by 0, and then IP address what we are here. So instead of 10.10 it will be 10.3, and the subnet mask will be like this 248, and then no shut. Exit fine, and then E0 by 1 IP address 12 by
Mm-hmm.
252 because slash 30 is okay. Okay, IP address is configured, and then how you can save, if you will write this command, write command is used to save the configuration, right? Okay, save the configuration of R1, and here in the topology we have to say that it's 10.3 not 10 dot, okay, and here is 20.3. Okay, fine. Okay, this is done. Now we'll come to R2. See, R2 has, okay, now tell me, R2 have how many interfaces? Here R2 router have how many interfaces? It has only two
Okay, a
interfaces.
little bit big.
It has two interface, right?
Yeah, two interface.
Two interface, E0 by 1 and E0 by 0. So I'll come here conf t. I'll come here interface E0 by 0. IP address 192.168.20.3, and the subnet mask is 248, and then no shut. Exit. Now come here again interface E0 by 1, which is WAN interface, IP address 12.1.1.2 252, no shut, right? And then save it. Simple configuration. IP configuration is saved. Now I will come to PC3, IP 192.168.20.1/29, and the gateway is 20.3. Very simple. Write save to save the IP. Come here, IP 192.168.20.2/29, and the gateway is 20.3. Save. Okay, now if you'll say, if you'll come to PC1 and you'll say that I want to communicate to 192.168.20.2 computer. See, no communication, destination host unreachable, right? Now, when you are getting these messages, and why you are getting these messages, and who is giving you this message? Your gateway. Your gateway is saying that no, I'm not able to reach to that network. And if you'll come to R1 and you say that, if you are checking this, so IP route. See, your R1 doesn't know about 20 network, right?
Mm-hmm.
Right? 20 network. So that's why your R1 cannot reach that 20 network, because it's unreachable. Okay. Now, so what you have to do? You have to configure routing. Now see. Now tell me. First thing, see the process of a static routing. First thing, design your network. First thing. So this we have already done, right?
Mm-hmm.
Okay. Second part. Second part is design and connect, you can say design and connect your network devices. So this is already done, you can say. Second part, configure configure IP addresses.
Mm-hmm.
Okay, so now what we have to do here, configure IP addresses. So this also done, right? Number 3,
Mm-hmm.
now you find how many networks you have in this total design. How many networks you have, tell me. Total, in
Mm-hmm.
total network, this total design, how many networks you have?
We have two.
Two network. Okay, which one?
Mm.
You're saying about this one, right? One is this,
Yeah, yeah.
one is this one, right? And
Mm-hmm.
what about this one? This is also one network, right? This one.
Okay, okay.
So we have total three networks. Total three networks, right? Okay, now verify R1 routing table. Come, let's verify. So come to R1 and type this command show IP route to verify this routing table of R1. Now R1 know about how many networks?
Aaron knows about two networks.
Two networks. Very good. C means connected. Okay, two network. But R1 should know all networks. So R1 is missing with one network, right?
Mm-hmm.
And who have that network? Router 2 have that network, right?
Mm-hmm.
So see how to configure your static routing. So you have to come here, conft, you have to say IP route. I want to reach 10.20.0. Subnet mask is this. Sorry, 20.0. Subnet mask is 248. And that network is reachable via one of my neighbor, and that neighbor is my router 2, and that neighbor IP is 12.1.1.2. So you write here 12.1.1.2.
Mm-hmm.
Simple. And then if you come and check, so IP route, see that route is there. So you have all these three network, right? Okay, now
Mm-hmm.
if you will come, see, now you have different message. Request timeout means your, see, are you getting? See, now who
Yeah.
is replying?
That's
your
right.
your packet is coming to this PC 20.2, but that PC is replying also. But router 2, when that router 2 wants to reply you, so IP route, see, router 2 don't know about 10 network. Are you understanding?
Mm-hmm.
Okay,
Mm-hmm.
and if you want to verify also, if you'll run some kind of debugging message, debug IP icmp. Okay, let's run debug IP icmp. Okay, and if you're trying to ping from here, see 20.3, see R3 is saying that yes, see, someone is 10.1 trying to communicate to me, right?
Mm-hmm.
Okay, but when I'm replying him, okay, when
Mm-hmm.
I want to reply him, okay, but that information is not in my routing table. So for that you have to add the reply packet on, or to stop this debugging, then come here conf t, type here IP route. I want to add same 10.0 255.255.255.248, and to reach that, R2 is saying to reach this network I have to add this R1 IP address, right? R1 IP address. So see, R1 IP address is there now, and after that if you are checking, so IP route, see, 20 is 10 is there as a static route, right? And now if PC1 is trying to communicate, see, communication is there, okay, and both routing table is like this. See, 3 network, and here also 3 networks, so all is communicating. Okay, now you will
Mm-hmm.
say that, see here, you can see in the routing table, this is what administrative distance 1 for a static route. Okay, now you will say that, okay, do we have any other option to configure static routing? Yes, here we have configured this with next hop, like we have configured like this. Okay, we have configured IP route 0 192.168.20.0 and gateway is like this. We have configured like this. So this configuration is known as next hop IP address, right? We have another process
Mm-hmm.
also which can help you, okay, uh, to add static route. So that process is, for before that process we have to remove the older process, right? So we'll come here, and to remove we will just say no in front of your statement. Okay, no, remove
Mm-hmm.
this, and now come to your R2 conf t. Here also you say no. Okay, and now if you check your routing table, see, do show IP route in your configuration mode also, no problem. See, route has been removed. You come here and check, do show IP route, no route. And after that, if the PC is trying to communicate, no communication, destination host on retrieval. So see how we can write it. Okay, IP route, instead of writing this, okay, instead of writing like this, we have to write like this. Okay, what is your exit interface? So my exit local router exit interface is e0/1, e0/1. Okay, and both, you can combine both or you can write same single. See here. Okay, now you can come here to R2 also. My exit interface is e0/1, and after that if you check the show IP route, see, static directly connected network. See, here also come, so IP route directly connected network as a static. And now if you will come to this PC and try to communicate, see, communication is there. Okay,
Mm-hmm.
okay, now you will say, okay, do I have any another process? Yes, you have another process for faster communication. You just say no. Here also come conf t, say no. Okay, in front of the statement you say no. Now you configure as a new. Okay, new, what configuration? New configuration, that is known as recursive communication configuration. Okay, you say that I want to use both command in a single statement. Okay, two, and here also 12.1.1.1. Fine. And now you check your routing table. See, and come here and check your routing table. Okay, and now is this time your communication will be faster than, okay, okay. So like this you can configure, okay, your static routing.
And the packet tracer is gonna be the same
Yeah, in packet tracer also it's same, no problem.
because now you have to be with me so I can understand GNS3,
Yes, 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 no problem.
the physical.
Yes. Okay, now we will understand about static routing load balancing. Okay,
Mm-hmm.
so see how static routing load balancing works. So for that we have to configure a new lab, static load balance.
What is the what's load balancing doing? What is it doing?
Load balancing means half traffic from one way and half traffic from another ISP. See, in our
Mm.
previous lab, we had only single exit interface, right? So all the
Yeah.
traffic will go via that interface. But when you have
Mm.
multiple path like this,
Mm.
when you have
Mm-hmm. Mm.
when you have multiple ISP, see this is your router one, okay,
Mm-hmm.
and this router one have is connected with two ISP, ISP one, okay, and ISP2, and it has to
Mm-hmm.
reach one internet. So your router will forward IP the data from ISP1 or ISP2. How? Right?
Mm.
So this is load balancing. Okay.
Mm.
Okay. So let's see this.
Okay. Oh, like in the office here, we have to net ISP.
Yes, yes. In
We
that
have
we have to define load balancing.
okay.
Okay. So for that we have to take four routers. For router one, router two, router three. So we'll see here, here, and here. Then we have to take one Ethernet switch. Okay. After that we have to take some PCs. Okay, this is our switch one here. The PC1, PC2, PC3. Okay, now part of connectivity. Okay, now you have to click on this ABC to have the interface label. E0 by this. Okay, fine, fine. Here also is okay. Now we have to align it. Alignment is very much important to understand this lab perfectly.
Mm-hmm.
Okay, so you select this. First, you change this symbol to ISP. Okay. Okay, so this is your ISP1 and ISP2. We'll changing the host name. Change host name R3 is acting as a ISP2, ISP1. Fine. This is your ISP1, and this is your ISP. ISP. And this is your server, you can say, like internet servers. Okay,
Mm-hmm.
yes. So you can change symbol to internet server. Internet server. So this is your server, and you can change host name to internet. Okay, fine. See, if you will do like this, so like if you will configure like this, so your boss will understand that, okay, which type of network is this one, okay, how it is connected.
Mm-hmm.
That's why I take time to like design, so a student can understand how I am changing the icon. Because in my slide you will find like this, so you will not know whether these devices are router or switch. So the ISP1 and ISP2 is what? Router. Internet, that server is also router, right? I just changed the symbol.
Mm-hmm.
Yes. So now here we are using our IP address. Okay, 12.1.1.0/30. Here we will be using 13. Here we are using 24.1.1.0, and here we are using 34. Okay, fine. Okay, and after that, loop back 1.1.1.1/32, 2.2.2.2/32. Fine. Okay. Now you can say that this is our static routing load balancing. Okay. So immediately we will configure the IP addresses first. So here we can say that we are using 192.168.10.0/24 network. Start all the devices. Okay. And then after we'll take a console of that. So for that we have to click here. So the first process, connectivity designing, is done. Now IP configuration. Okay. So PC1, internet is in the last. Okay, fine. So we'll come to PC1, same thing, IP 192.168.10.1/24, and the gateway is 10.10. Save. IP 192.168.10.2/24, 10.10. Save. PC3 IP 192.168.10.3/24 and then 10.10. Now router 1 has three interface, so I'll come here, interface E0/1 IP address 12.1.1.1, no shutdown, and then exit. Okay, interface E0/2 IP address is 13.1.1.1, and then no shut. Then exit, then interface E0/0 IP address is 192.168.10.10. Okay, no shut, and then save it, exit and save it. Now come to your ISP1 conft interface E0/1 IP address is 12.1.1.2, 252, no shut, and then interface E0/2 IP address is 24.1.1.1, no shut, 2 IP, save it. Now we'll come to ISP2. ISP2 has also 2 IP address, so I'll come here, country interface E0/2 IP address is 13.1.1.2, no shut. Now see, do not get confused. See, if we are using this, so here we are using 192.168.10.10. Okay, and here we are using, like .1. Okay, here we are using .2. Okay, same thing. Here we are using .1. Here we are using .2. 13.2. Here we are using .2. Okay, here we will be using .2. Okay, .1, not part of .1. So here .1 and .1. Okay, so we have configured ISP E0/2. ISP has E0/3. So I'll come here, interface E0/3 IP address is 34.1.1.1, and then Control Z, write, save. Now internet has 4 interface, 2 loopback, 2 physical. So country interface loopback 1, then interface loopback 2. Okay, exit, then interface E0/2 IP address is 24.1.1.2, 252, no shut. Then interface E0/3. Okay, IP address is 34.2, no shut. Okay, then interface loopback 1 IP address is 1.1.1.1, then interface loopback 2 IP address is 2.2.2.2. Okay, and then save. And after that, the command, if you'll come here to router 1, check that command, so IP interface brief exclude on assign. Okay, IP is okay, status is okay, everything is okay. Now we'll come to ISP1. Okay, fine. ISP2, fine. Internet, fine. if all interface status is up and protocol up, then we will move to another configuration. What is that another configuration? Static routing. So let's come here, R1, say conf t IP route. Now tell me, you want to reach only this to internet IP, right? You can say this is Google address or something like that. Google. Okay. So you want to reach this google.com. So this google.com address is 1.1.1 and 2.2. Simple. Tap. Okay, no problem. Okay, so this Google address, we have to reach this Google address. So to reach this Google address, what is the destination address? So you have to say that, okay, IP route, I want to reach 1.1.1.1 network, and the subnet mask of that network is /32. Yes, but I know my ISP address. Okay, so you'll say, okay, my ISP address is 12.1.1.2. Okay, now you will say, yes, I have my another ISP also. Okay, which is, what is the address of that ISP? See, you have one ISP 12.1.1.2 and then another ISP2 which is 13.1.1.2 here. You say, no, I have another ISP also which can provide me reachability to Google. You have to mention this, right? Now you will say, okay, one is done. Now we are remaining with two. Okay, so you'll say that, okay, yes, Google have another address 2.2.2.2. Yes, I can reach Google via another IP, another ISP, which is 13. Okay, now same thing. Okay, right? You have configured here, right? Okay, now you see that is not your configuration ISP router, but let me show you how ISP configure. ISP say that IP route 192.168.10.0. ISP will also configure routes 12.1.1.1. Then again IP route 1.1.1.1 via 24.1.1.2, and then again one more 2.2.2.2. Okay, this is the ISP1 configuration. Same configuration ISP2 will also configure to provide reachability. Conft IP route 192.168.10.0, subnet mask is this. Okay, but reachable via 13.1.1.1. Then let me copy this. 34 to 2.2.2.2. Okay, ISP is done. Now internet also has to reach you, right? Internet, when internet wants to reach your network, so your internet also must know about your network. So here you have to configure only single path, that conf t, you have to say IP route 192.168.10.0 255.0 reachable via 24.1 and 34.1. Simple. And you check your routing table here. So IP route, yes, reachable, and here also reachability. So IP route, yes, you have here. Okay, you can reach via 2 ISP, right? Now, but if you are coming your PC1 and now if you are trying to ping 192, ping to 1.1.1.1, you are able to reach, right? No problem. Okay, and if you are trying to ping 2.2.2.2, yes, you are able to reach, no problem. But now tell me, your R1, when R1 is sending data for PC1, so the PC1 data is, your R1 is following ISP1 path or ISP2 path. You don't know, right? So you have to check this one. You have to come and say, okay, trace. Please find how is going. Okay, is going via ISP2. Trace 2.2.2.2. Okay. Okay, now let's try PC2. Trace 1.1.1.1. Okay, trace 2.2.2.2. All is going via ISP2. Okay, trace 2.2.2.2. Okay, here I have configured wrong IP address. /24.192.168.10.10. Okay, all is following this ISP2. This one, this path. Okay, and now check why they are following this path. If you'll check here routing table, see, can you see here, this one is first listed. Who is first? 13 is first, right? And 12 is in second. Okay, yes, but
Yeah.
now you will say, no, I don't want load balancing. I want to make this link as a primary link. Okay, and this link as a secondary. Okay, if primary will fail, then secondary will work. Okay, I don't want load balancing, no problem. Okay, so in that condition you have to configure advanced static route. Okay, and that advanced static route is known as
Okay.
floating static route. Okay, now see how it works.
Okay.
Simply, what you have to do, you have to come here on R1. First you have to delete the configuration, so run section route. So all this route, what you have to take, you have to copy this route, you have to open notepad, paste in notepad, and in front of all you say first no, 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 and then no. Control A, C, copy all this and then come here. Faster configuration, otherwise you have to do one by one, and then right click paste. Delete all the configuration. Once you delete and check routing table, see, no route, no static route. Now you have to configure the floating static route. Now see, you have to say and come and say that I want to make configure routing table, right? So I want to say IP route, make this as a primary. So for primary you give administrative, any administrative distance. Okay, you say I want to give 10. Okay, for reaching 1, okay, this is primary. Okay, and for reaching 2 also I want to make this as a primary. Okay, but again for reaching 1 I want to make this as a secondary 13.1.1.2 secondary, so I'll give higher administrative distance. Okay, 13.1.1.2 higher administrative distance. Now, and you check your routing table, so IP route, do you have 13 listed here? No, no 13, right? And if you are
Mm-hmm.
tracing now, see your all packet is going via ISP1, no ISP2. See here, all is via ISP1. And now if you ping continuous ping and see ping 1.1.1.1 minus C. Now see, continuous pinging is going. Now what will happen when this primary link will down? For example,
Mm-hmm.
maybe if you'll come here and say that okay, primary link conf t interface e0 slash 1 is down for a while, is shut down. Now see, network goes down, and now you see after some time network will go down. And if you check the routing table, okay, this one is not changing. Okay, no shut. Okay, if you come to R1 and say this connected link go down, no problem. Conf t, okay, interface, before you check your routing table, okay, so IP route, you can see this routing table. Now if you come here, maybe the interface which is connecting to ISP1, interface E0 by 1, interface E0 by 1 is down, shut. And now you see, now if you check your routing table, so IP route, see automatically 13 came, right? Earlier it was 12, but automatically 13 came. See, and now when the 13 came,
Mm-hmm.
see, you will see after some time it will start communicating. Let's come to PC2, ping 2.2.2.2. See, it's pinging. Control C, ping 1.1.1. Okay, you can see that PC2 is pinging to 2 and PC 1.1.1. See, they are pinging. And if you trace, it's going via ISP. So this is all about your static route, how to configure, how to create load balancing. In that also load balancing, you can define that no, I don't want load balancing. I'll say that okay, I want to make this link as a primary and this link as a secondary. Why? Why you want to make this link as a primary? Because my ISP1 connection is 10 Mbps, right?
Mm-hmm.
Okay, and my ISP2 connection is 5 Mbps. Okay, so and in that case I do not want load balancing. Why? Because one packet will go fast and one packet will go slow,
That
because
was
yes,
mm-hmm.
so that's why I
Mm-hmm.
want to make this link as a primary. Okay, and if the primary will fail, automatically all the load will go to secondary.
Mm-hmm.
Okay, so this is all about your static routing. Okay,
Mm-hmm.
and how to verify, I have already told you that if you'll come here, so IP route is used to verify your routing table. S means static, and you can see here administrative distance what we have changed to 10 and 20. Lower is better, higher is not good. Okay, higher is second
Mm-hmm.
better. Okay, see, if you will assign administrative distance, then it will be taken by what you are going to assign. But if you will not assign, so by default the administrative distance is 1.
Mm-hmm.
Okay,
Okay. Is it good? better than to assign or to
No,
get
see,
it
if you want to
automatically?
make this as a primary, so no need to assign. But here, if you want to make secondary, so assign higher. Higher. Default is 1.
Okay.
Okay. Okay. So tomorrow we will be working with default routing. Okay.
Mhm.
Okay.